Welcome to Medico Important Simplified channel. So today we are going to cover a very important topic in community medicine, which is vaccine and cold chain. So vaccines. So what are vaccines? Basically, vaccines are basically examples of active immunity. And if you see, there are certain MCQs. The first vaccine was a smallpox vaccine. The first vaccine discovered was smallpox vaccine. And the term vaccine was given by Louis Pasteur. The term vaccine was given by Louis Pasteur. And the term vaccination was given by Edward Jenner. So vaccines are basically active immunity. The first vaccine discovered was smallpox vaccine. Vaccine means what the word vaccine was given by Louis Pasteur, and vaccination term was given by Edward Jenner. Okay. And Edward Jenner is the one who discovered smallpox vaccine actually. So vaccination is Edward Jenner. Vaccine was given by Louis Pasteur. Now let's look at the types of vaccines. Now moving on to the types of vaccines, we have live vaccine. So what are live vaccines? So live vaccines are vaccines that having reduced virulence or disease causing capacity, but the antigenicity is going to be retained. So in live vaccines, the virulence of the organism is going to be reduced. So there is a reduced virulence, or I can also say that the disease causing capacity is reduced. So there is reduced virulence or disease causing capacity. So virulence is decreased or the disease causing capacity is decreased, but capacity is decreased. But the antigenicity is going to be retained. Antigenicity is going to be retained. So that is live vaccines. So the role of live vaccine is the virulence is decreased or the disease causing capacity is decreased, but the antigenicity itself is going to be retained. Live organisms will multiply in the host and the resulting antigenic dose is going to be larger than what it is injected. So what does it means is, in live vaccines, all the live organisms will be going to the host and they will be multiplying in the host, because of which it will be resulting in an antigenic dose which is larger than what it was injected. So if say suppose a dose of X is injected, then it's going to be more, 10 times the X is going to be the dose inside the host. There is going to be multiplication. Now live vaccines have all major and minor antigenic components, and live vaccines engage certain tissues of the body. So these live vaccines will be engaging certain tissues of the body. Example, the intestinal mucosa by oral polio vaccine. Sometimes one good example for vaccines engaging certain tissues of the body is oral polio vaccine. In oral polio vaccine, there is going to be intestinal mucosa is going to be invaded. Intestinal mucosa will be invaded in oral polio vaccine, and it's a good example for vaccines engaging certain tissues of the body. There may be other mechanisms such as persistence of latent virus. So this is all about live vaccine. So I will give you some examples of live attenuated vaccine. So examples of live attenuated vaccines is BCG vaccine for tuberculosis, yellow fever vaccine, yellow fever vaccine, and then oral polio virus, okay, oral polio vaccine, and measles also is live attenuated. Mumps is also an example of live attenuated vaccine, and rubella, typhoid. So yeah, typhoid, varicella, rotavirus. Rotavirus is also a live attenuated vaccine. Varicella, chickenpox, again live attenuated vaccine, and cholera. So cholera is a live attenuated vaccine, and okay, so these are some examples of live attenuated vaccine. I am revising once again. BCG, yellow fever, oral polio vaccine, measles, mumps, rubella, typhoid, varicella, rotavirus, and cholera. All these are examples of live attenuated vaccine. Now moving on to the next type of vaccine, which are your killed vaccines. So killed vaccines, so these are inactivated or killed vaccines produced by a growing virus or bacteria in culture media. Okay, so how these inactivated or killed vaccines are prepared is, all these growing virus or bacteria in the culture media are going to be grown, and then inactivating them. So we are going to inactivate these organisms. We are going to inactivate these organisms by either heat, okay, by either heat or either by chemicals. Okay, we are going to inactivate all these microorganisms, and now when injected into the body, they stimulate active immunity. So basically, killed vaccines is where there is going to be all the bacteria or the growing virus will be there, but we are going to inactivate them. So inactivating by heat or chemicals is going to be producing your killed vaccines, and now when they are produced into the body, they will be stimulating active immunity. So let's look at some important examples of killed vaccine. First is injectable poliovirus vaccine. Okay, injectable polio vaccine. And then you have rabies. Again, rabies is also a killed vaccine. Rabies, and then your pentavalent vaccine is a killed vaccine. Pentavalent vaccine is a killed vaccine. And then Japanese encephalitis again is a killed vaccine. And pertussis is a killed vaccine. So typhoid cholera can be in both the forms. It can be either in killed also. So again, typhoid cholera can be live as well as killed forms. Both forms are available. Then you have pertussis, influenza, injectable polio virus vaccine, rabies, pentavalent, Japanese encephalitis. All these are examples of killed vaccine. Now moving on to the next type of vaccine, which are your subunit vaccine. So what do you mean by subunit vaccine? See, subunit is made up of a single or multiple antigenic components of a microorganism. So there is a microorganism. In subunit vaccine, see, the entire microorganism may not be there, but maybe a part of the microorganism is going to be going to be producing the immunity. So it consists of either single or multiple antigenic components, single or multiple antigenic components of a microorganism. So that is subunit vaccines. So in subunit, the entire whole microorganism may not be injected, but just a single or a multiple antigenic component of a microorganism that are capable of simulating a specific immune response sufficient to protect from a relative pathogen infection or from a clinical manifestation of a disease. Okay, so subunit vaccine is made up of what? Single or multiple antigenic component of a microorganism that is capable of producing an immune response. Now there are various again the subunit, there are various categories in subunit vaccine, or we can say various types of subunit vaccines. The first one is toxoids. So what are toxoids? Toxoids, you have exotoxins from the organisms, and they are going to be detoxicated and then used in preparation of vaccines. See, toxoid vaccine is basically exotoxins from the microorganisms are taken, and these exotoxins will be detoxicated. After detoxification, they will be injected. So what is the best example for toxoid vaccine? It is obviously your TD, tetanus toxoid. Okay, TD vaccine, tetanus toxoid vaccine. Now after this we'll have the next category of subunit vaccines, which is your protein vaccines. So protein vaccines, okay, protein vaccines, if you see, immunization with a single protein or combination of proteins from a pathogen. Okay, immunization with a single protein or combination of proteins from a pathogen even is sufficient to stimulate a protective immune response. So what do you mean by protein vaccine is even a single protein, okay, or a combination of protein from a pathogen can be are sufficient to produce an immune response. So examples are licensed acellular pertussis vaccine, because this acellular pertussis vaccine is prepared from bacteria pertussis influenza, okay, from the bacterium pertussis, and influenza vaccine is prepared from hemagglutinin as well as neuraminidase. So if you look at this influenza vaccine, it's prepared from both hemagglutinin and neuraminidase. Hemagglutinin as well as neuraminidase both are proteins. So it means that even a single protein or a multiple protein of the microorganism is sufficient to produce immune response. So the best example would be acellular pertussis, okay, which is going to be prepared from the bacterium pertussis, and influenza virus, because influenza virus is prepared by the two protein. Okay, influenza vaccine is going to be prepared by two proteins. What are the two proteins? Hemagglutinin as well as neuraminidase. Okay, so toxoids are over, protein vaccines are over, and then we have the third category, recombinant protein vaccines. Okay, recombinant protein vaccines, as well as we have the fourth category, that is polysaccharide based vaccines. Okay, recombinant protein vaccines and polysaccharide based vaccines. And then the next one is going to be your conjugated vaccines. So again I'm revising. Under subunit vaccines, you have toxoids, you have protein vaccines, you have recombinant protein vaccines, and after recombinant protein vaccines, you have polysaccharide based vaccines, and the next one, conjugated vaccines. Toxoids, protein vaccines, recombinant protein vaccines, polysaccharide based protein vaccines. Okay, polysaccharide based vaccines and conjugated vaccines. Now let's look at each one of them. So protein vaccines and toxoids are over. So what do you mean by recombinant protein vaccines? Recombinant protein vaccines are prepared using recombinant DNA technology. Example, the best example for a recombinant protein vaccine is hepatitis B vaccine. Produced large amounts of hepatitis B surface antigen. So hepatitis B vaccine is will be produce large amounts of hepatitis B surface antigen. So that is recombinant protein vaccine. So what do you mean by recombinant protein vaccine? It is basically by our DNA technology, recombinant DNA technology. Example is hepatitis B. Okay. So best example is hepatitis B. Hepatitis B vaccine. There are so much of hepatitis B surface antigens will be produced by this hepatitis B vaccine. Now next moving on to polysaccharide based vaccine. Polysaccharide based vaccines means the polysaccharide coat of the bacteria used in producing the vaccine. So what do you mean by polysaccharide based vaccines? The polysaccharide coat of the bacteria is going to be used to produce what? Vaccine. Okay, that is the meaning of polysaccharide based vaccine. So example is going to be Haemophilus influenza B vaccine. Okay, Haemophilus influenza B vaccine and purified protein. Okay, just remember under polysaccharide vaccines, just remember Haemophilus influenza B vaccine. Okay, now next is conjugated vaccine. Conjugated vaccines means children under 2 years of age. Okay, children under 2 years of age do not respond well to antigens such as polysaccharides. So children, if you look at the children under 2 years of age, they will not respond well to antigens such as polysaccharides. Therefore, conjugate vaccines are going to be used in children. So conjugated vaccines is children under 2 years of age do not respond well to antigens. So what kind of antigens? Antigens like polysaccharides. Okay, so children less than 2 years of age do not respond well to the antigens such as polysaccharides. Therefore, the conjugate vaccines are going to be used in children. Now, this conjugate vaccine means both protein plus polysaccharide. Now, they will be eliciting a stronger immune response and immune memory in the children. So, they elicit a stronger immune response and immune memory in children. Example is pneumococcal conjugate vaccine. The best example for conjugate vaccine is pneumococcal conjugate vaccine. Okay. And meningococcal vaccines. These are all the examples of conjugated vaccines. Now only the components of organism is going to be used in making the vaccine, and that is only subunit vaccine. Remember, in subunit vaccine only the components of the organism are used to make the vaccine. So the for example is going to be polysaccharide vaccine. In polysaccharide vaccine you have both meningococcal as well as pneumococcal. Okay, and proteinaceous vaccines you have acellular. You have acellular. For protein vaccines you have acellular pertussis vaccine. So remember, protein vaccine example is acellular pertussis vaccine and influenza vaccine using hemagglutinin and neuraminidase. In toxoids you have tetanus toxoid. In recombinant protein vaccine you have hepatitis B. And in polysaccharide based vaccines you have Haemophilus influenza B. Okay, and the conjugated vaccines you have pneumococcal and meningococcal vaccines. So we finished live, killed and subunit vaccine. Now next moving on to, so the next we'll be moving on to the fourth type, live, killed, subunit. We finished 3 types, and the next one is going to be a combination vaccine. So what is this combination vaccine? Combination vaccines or basically more than one kind of immunizing agent is going to be included in the vaccine. Okay, so more than one kind, it's going to be more than one kind. That is, combination is like pentavalent. In pentavalent you have what? In pentavalent is a combination. Pentavalent vaccine is a combination of diphtheria, pertussis, tetanus, okay, plus hepatitis B, plus Haemophilus influenza. Hib vaccine. So pentavalent vaccine is diphtheria, pertussis, tetanus, hepatitis B vaccine and Haemophilus influenza B. Okay, and DPT, MMR is also again a combination vaccine. Now let's look at some important strains used for vaccines. So let's look at some important strains used in vaccine. First is going to be in chicken pox. So what strain do we use for chicken pox? It is the Oka strain. In chicken pox we use the Oka strain. Then next, moving on to measles. All these are MCQs. In measles it's going to be Edmonston Zagreb strain. Very famous strain is Edmonston Zagreb strain. In measles it's going to be Edmonston Zagreb strain. Next is going to be BCG. Very important. BCG, what strain do we use? Danish 1331 strain. Danish 1331 strain. Chickenpox, Oka strain. Measles, Edmonston Zagreb strain. BCG, Danish 1331 strain. Then comes the rubella. In rubella we use RA27/3 strain. So rubella what strain? RA27/3 strain is used. Then in Japanese encephalitis we use SA1414-2 strain. So SA1414-2. Japanese encephalitis SA1414-2 strain is used. Then in yellow fever 17D strain is used. H1N1 you have A7 California strain. Okay, that's not very important. In typhoid what strain? In typhoid it's going to be typhoid TY21A strain. TY21A strain. So next, very important, mumps. Mumps we use the famous Gerald Lynn strain. Okay, for mumps it is going to be Gerald Lynn strain. For malaria RTS, okay, it's not very important. Yeah, just remember these strains alone. Again revising: chickenpox, Oka strain; measles, Edmonston Zagreb strain; BCG, Danish 1331 strain; rubella RA27/3 strain; Japanese encephalitis SA1422 strain; yellow fever 17D strain; typhoid TY21A strain; mumps Gerald Lynn strain. So these are some very important strains to remember, which can be asked in your MCQs. So live and killed vaccine can be together, okay, and two live vaccines, very important. Two live vaccines can be simultaneously given, but the site of administration should be different. So one important rule, so let's look at some rules in vaccination. That is, two live vaccines can be given simultaneously. It can be given simultaneously, but there is one rule, that is the site of administration must be or should be different. Okay, that is if you're giving MMR vaccine as well as Japanese encephalitis vaccine together, so definitely one should be given in one site and another one should be given in a different site. So two live vaccines can be given simultaneously, but the site of administration should be different. Now when two live vaccines are required, they should be given either simultaneously at different sites or with an interval of 3 weeks. Okay, say suppose two live vaccines you want to give. Now you are saying that okay, there are two live vaccines that must be administered. Either you can give both of them simultaneously but at different sites, or else you can give these two vaccines at an interval of 3 weeks. So two live vaccine can be given simultaneously, but the site of administration can be different. But in case you are giving in the same site, okay, the interval must be of at least 3 weeks. 3 weeks interval should be there. Now in case of live vaccines protection, okay, is generally achieved with a single dose of vaccine. Okay, so in case of live vaccines, in case of a live vaccine, the protection is generally achieved with a single dose of vaccine. So even a single dose, okay, generally in live vaccines a single dose of vaccine is enough. Okay, it is sufficient to produce the protection. So in live vaccine a single dose is also enough to produce protection. So in case of live vaccine, protection is generally achieved even with a single dose of vaccine. Now an additional dose is given to ensure the seroconversion. Example, 95 to 98% of the recipient will respond to a single dose of measles vaccine. Now the second dose is going to be given to ensure that 100% persons are going to be immune. So generally even a single dose. So one example of live vaccine is what? Tell me some one live vaccine. So say suppose measles vaccine, even a single dose is enough to protect around 95 to 98% okay, protection. So when do we give second dose then? Just to ensure 100% of persons are going to be immune. Now booster doses are not required when live vaccines are administered. As I already mentioned, that single dose is sufficient, okay, to produce protection. Therefore booster doses are generally not required for live vaccines. This is the third rule. So first rule is both can be given simultaneously but at a different type and interval of 3 weeks. Second rule is live vaccines, even a single dose is enough to produce the protection. And the third rule is booster doses, thereby it's not required for live vaccines. Now one exception to this rule, okay. So generally for live vaccines booster doses are not given, but the exception to this rule is oral polio vaccine. Because for oral polio vaccine alone we give one booster. Oral polio vaccine for 0 dose, first oral polio vaccine birth dose is given, and oral polio vaccine 1, 2 and oral polio vaccine 3 are given 6, 10 and 14 weeks respectively. Okay, and one oral polio vaccine booster dose is given around 16 to 24 months. Okay, so yeah, oral polio vaccine booster dose is given around 16 to 24 months. The immunity provided by these doses is not sufficient. Therefore the booster dose is going to be required in case of OPV. Now inactivated vaccines If you see, the inactivated vaccines are usually safe but less efficacious than the live vaccines. So inactivated vaccines are usually going to be safe. Okay, so but they are going to be less efficacious than the live vaccines. Killed vaccines require a primary series of 2 to 3 doses. If you see the killed vaccines, so if you look at the killed vaccines, they will definitely require, they're already inactivated, and therefore they'll be less efficacious. So killed vaccines all will be requiring at least a primary series of 2 to 3 doses of vaccines to produce an adequate antibody response. So to produce a proper in order to produce adequate antibody response, at least we need around 2 to 3 doses are required. Okay, now an adequate antibody response, and also booster doses are going to be required. Also booster doses will be required. In general, the toxoid preparations are highly efficacious, okay, and they are safe immunizing agents also. So if you look at the toxoid, toxoid preparations are all highly efficacious. Okay, they are highly efficacious, as well as these are all toxoids are safe immunizing agents. They are safe also, they are safe immunizing agents. Next, moving on to the polysaccharide and conjugate vaccines are stereotype specific. Okay, now recombinant vaccines require an adjuvant to enhance efficacy. So the next point to remember is recombinant vaccine. So recombinant vaccines, if you look at recombinant vaccines, they require adjuvant. Okay, they require adjuvant in order to enhance efficacy. So very important, toxoid vaccines are highly efficacious, they are safe immunizing agents, whereas recombinant vaccines, they require adjuvant. Okay, adjuvant for enhancing their efficacy. COVID vaccination drive in India was started in 16 January 2021. It was just a date, it's not very that important. Okay, so we have almost covered these vaccines. Okay, now let's look at certain conditions and contraindications. So in pregnancy, remember, first condition, pregnancy. So in pregnancy, can we give vaccines? All the live vaccines except yellow fever are going to be contraindicated. Okay, so in pregnancy, all live vaccines, no live vaccines must be given, except for what? Which vaccine? Which is the only vaccine which we can give in pregnancy? Yellow fever. Yellow fever is not contraindicated in pregnancy. Now fever. Next, fever. The condition is yellow fever, and the contraindication is going to be egg allergy. So what is going to be contraindicated for fever? Typhoid vaccines are definitely contraindicated. In symptomatic HIV, adults, all the live vaccines, okay, except measles, MR and MMR, varicella are going to be contraindicated. In newborn, all the live vaccines are contraindicated except for oral polio vaccine, measles and BCG. Okay, so remember, if there is HIV, if at all there is symptomatic HIV, in case of symptomatic HIV in children, all are going to be contraindicated. Okay, all are contraindicated except for oral poliovirus vaccine, measles and BCG. And in case of adults, all are going to be contraindicated except for measles, MR and MMR and varicella. Okay, these are all not contraindicated. Now, progressive neurologic disease or uncontrolled epilepsy or encephalopathy, definitely pertussis vaccine is going to be. In case of encephalopathy, or any progressive neurologic disease, pertussis vaccine is contraindicated. Okay, is contraindicated. We should not give pertussis. In immunosuppression and corticosteroids, all live vaccines are contraindicated. So all live vaccines are going to be contraindicated in case of immunosuppression, okay, as well as the use of corticosteroid. Anaphylaxis to prevent previous dose, current serious line, all these. Now let's look at the AEFI, which is adverse event following immunization. Yeah. So let's move on to the next important topic. So the next topic is AEFI. What is AEFI? Adverse events. Okay, adverse event following immunization. So adverse event following immunization. Let's look at the definition first. So the definition of adverse event following immunization is, it is any untoward medical occurrence. Okay, untoward medical occurrence which follows immunization and which does not necessarily have a causal relationship with the usage of the vaccine. So the definition of AEFI is any untoward medical occurrence which follows immunization and which does not necessarily have a causal relationship with the usage of the vaccine. That is known as adverse event following immunization. So any untoward medical occurrence following immunization which does not necessarily have a causal relationship with the usage of vaccine. Now there are cause specific type of AEFI, and let's look at each of the definition. The first one is vaccine product related reaction. So the first reaction is vaccine product related reaction. So any adverse event following immunization, okay, an adverse event, an AEFI, an adverse event following immunization that is caused or precipitated by a vaccine due to one or more of the inherent properties of the vaccine product is known as vaccine product related reaction. Then next, number 2, we have vaccine quality defect related reaction. So what is this vaccine quality defect related reaction? So an AEFI, an adverse event following immunization that is caused or precipitated by a vaccine that is due to one or more quality defects of the vaccine product. Okay, that is precipitated or caused by a vaccine that is due to one or more quality defects of the vaccine product, including its administration device, okay, as provided by the manufacturer, is known as vaccine quality defect related reaction. So what is vaccine quality defect related reaction? And any AEFI that is caused or precipitated by the vaccine that is due to any quality defect of the vaccine product, that is going to be vaccine quality defect related reaction. Okay, so it just quality defect reaction also includes the administration device, okay, as provided by the manufacturer. The next one is immunization error related reaction. Very important. Immunization error related reaction. What is this? So immunization error related reaction means an AEFI that is caused by inappropriate vacant or handling. Okay, there is inappropriate handling. Immunization error related reaction means there is inappropriate handling, prescribing or administration, and thus by its nature is going to be preventable. That is immunization error related reaction. It means there is a program error. So that how this error can occur, either there is inappropriate handling or inappropriate prescribing or inappropriate administration, and that is why this is so preventable. Then the next one is immunization anxiety related reaction. So what is this immunization anxiety related reaction? An AEFI arising from anxiety about the immunization is immunization anxiety related reaction. Then the next one is coincidental event. So when do we say it's a coincidental event? So an adverse event following immunization that is caused by something other than the vaccine product, okay, is known as coincidental event. It can be immunization error or immunization anxiety also. So immunization is used in these definitions means the usage of vaccine for the purpose of immunizing individuals. Okay, usage of vaccine for the purpose of immunizing individuals, and usage includes all processes that occurs after a vaccine product has left the manufacturing or packaging site, that is handling, prescribing, administration of the vaccine. All this will be coming under usage of the vaccine. Now let me list certain side effects of certain vaccines. Okay, now I'll first list down the vaccines. Okay, influenza vaccine, Japanese encephalitis vaccine, tetanus toxoid or tetanus. Okay, or tetanus diphtheria vaccine, yellow fever vaccine, oral polio virus vaccine, hepatitis B, measles, rotavirus, pertussis, BCG, MMR. Now I will be telling you, okay, the side effects of each of these vaccines, the important side effects which are generally asked in your MCQs. The first one is influenza vaccine. So what are the side effects of influenza vaccine? So here I am going to mention your side effects. Influenza causes anaphylaxis. Okay, it causes anaphylaxis, and a very important side effect of influenza is Guillain-Barré syndrome. Guillain-Barré syndrome, as well as ocular respiratory syndrome. So this is the very important side effect of influenza is Guillain-Barré syndrome. Remember. Now Japanese encephalitis causes certain neurologic events. Now tetanus toxoid or tetanus diphtheria vaccine can cause brachial neuritis, anaphylaxis. Okay, so brachial neuritis is a complication, also side effects of tetanus toxoid. Now, yellow fever, vaccine associated visceral tropical disease. Okay, so viscera tropical disease, it's not very important. OPV, paralysis, and vaccine associated paralytic polio, VAPP. Hepatitis B, hypersensitivity, shock, anaphylaxis. Okay, measles can cause toxic shock syndrome as well as febrile seizures. Very important, okay, very important side effect. Which vaccine causes interception? The answer is rotavirus. Rotavirus vaccine causes interception. So very important, rotavirus vaccine causes interception. Pertussis causes hypotensive hyporesponsive episode, persistent inconsolable crying. So yeah, this is also generally asked. Pertussis or DPT vaccine or pertussis will cause persistent inconsolable crying. Very important in pertussis and DPT, persistent inconsolable crying, hypotensive hyporesponsive episode, and fever. So DPT and pertussis, this is the important complication. In BCG, very important, the two important side effect of BCG vaccination, very frequently asked questions: osteomyelitis as well as suppurative lymphadenitis. So what are the two important side effects of BCG vaccination? Osteomyelitis and suppurative lymphadenitis. MMR vaccine causes thrombocytopenia. So these are certain side effects of some vaccines. Influenza causes Guillain-Barré syndrome, anaphylaxis. Japanese encephalitis causes certain neurologic events. Tetanus toxoid causes brachial neuritis. Yellow fever causes viscera like viscera tropical disease, and OPV causes paralysis and VAPP. Hepatitis B causes shock. Measles causes toxic shock syndrome. Rotavirus can cause interception. Pertussis or DPT can cause persistent inconsolable crying. BCG causes very two important side effects, that is osteomyelitis and suppurative lymphadenitis, and MMR causes thrombocytopenia. So which vaccine causes thrombocytopenia? MMR vaccine. Now let's look at the type of vaccines on basis of form. So vaccines can be either liquid form or powder form. Okay. So what are the liquid form vaccines? The pentavalent vaccine. Okay, the pentavalent vaccine. The injectable poliovirus vaccine. Tetanus toxoid vaccine. DPT. Okay, DPT and hepatitis B. All of these are liquid form of vaccines. And these vaccines can be reused. Okay, these vaccines can be reused for up to 28 days under their open vial policy. See, so under open vial policy, so under open vial policy, the liquid form of vaccines, okay, the liquid form of vaccines can be reused, okay, can be reused for up to 28 days, okay, can be reused for up to 28 days. And next is your powder form. So powder form, diluent is going to be added to your powder form. So powder form vaccines, powder form vaccines are otherwise known as freeze dried vaccines. Okay, very important. Powder form vaccines are otherwise known as freeze dried vaccines. And these freeze dried vaccines or powder form vaccines can be used up to around 4 hours. Okay, can be used for up to 4 hours. 4 hours. This is 28 days. So liquid form vaccines can be used up to 28 days, whereas powder form or freeze dried vaccines can be used up to 4 hours. Now examples of powder form and their respective diluent. Remember, in freeze dried vaccines or powder form vaccines we use a diluent. A diluent is going to be added and they are going to be used only up to 4 hours of reconstitution. Now let's look at some examples and their diluents. First, BCG. BCG. So BCG, what is the diluent used here? So the diluent used in BCG is going to be normal saline. Very important. So the diluent used in BCG is going to be, BCG will be normal saline. Next, coming to measles and MMR. These are all MCQs. In measles or MMR, the diluent used is going to be distilled water. Distilled water. So what is the diluent used in BCG? Normal saline. What is the diluent used in MMR or MR? Distilled water. Next, coming to Japanese encephalitis vaccine. So Japanese encephalitis vaccine to be used up to half an hour after reconstitution only. So JE vaccine can be used up to half an hour. Okay, can be used only up to half an hour after reconstitution. Remember, we already studied, usually powder forms all will be only can be used up to 4 hours of reconstitution, but Japanese vaccine alone is an exception because within half an hour of after reconstitution you need to use this vaccine. And the diluent used in Japanese encephalitis is going to be phosphate buffer. So again I'm revising. What is the diluent used in BCG? Normal saline. What is the diluent used in measles and MR vaccine? Distilled water. What is the diluent used in Japanese encephalitis? Phosphate buffer. Okay, so just we've almost covered everything about vaccines. Now we'll be moving on to next 2 important questions. Okay, we'll be covering the vaccine vial monitor, the cold chain. Okay, we'll be covering the cold chain. Okay, ice line refrigerator. All of this we'll be covering in detail. Okay. So write a short note on vaccine vial monitor. Okay, short abbreviation is VVM, vaccine vial monitor. So first, vaccine vial monitor, how does it look? So it looks like this. So basically So if you look at this diagram, this is what I've drawn as the vaccine vial monitor. So if you look at the first 2 diagrams, so they both are lighter colors, right? What you see in the inside is very lighter color as compared to the outer color. So which means The first two ones can be used. Okay, these two vaccines can be used, but the next one, where the inner color, okay, the inner color of the square is going to be equal to the outer color, so it means this vaccine cannot be used, and this is obviously very darker as compared. Inside it's black, it's more darker than outer color, which means this also cannot be used. So these both can't be used. Okay, can't be used. So this is the diagram of vaccine vial monitor. So vaccine vial monitor is a marker of cold chain maintenance of vaccine. So the first point is, it is a marker. It is a marker of cold chain maintenance. It is a marker of cold chain maintenance, okay, of vaccine. It is a marker of cold chain maintenance of vaccine. So it shows whether the vaccine has been damaged by heat or not. So this vaccine vial monitor will tell you whether the vaccine vial monitor or the vaccine is being damaged by heat or not. It reflects the potency of the vaccine. Very important. Vaccine vial monitor reflects the potency. Okay, it reflects the potency of the vaccine. So vaccine vial monitor will be reflecting about the potency of the vaccine. Now for liquid vaccine, okay, for any liquid vaccine, the vaccine vial monitor is going to be put on the body of the vial. Okay, so if you look at the liquid vaccine, the vaccine vial monitor is put on the body of the vial. Okay, so if this is the vaccine vial monitor, and this is the vaccine vial monitor where the vial is going to be on the liquid vaccine, and vial of a freeze dried vaccine, it will be above. See, if I am drawing you this is a freeze dried vaccine. Okay, this is a vial of a freeze dried vaccine or a powder form vaccine. And now next I am going to draw a liquid. Suppose this one, this is a vial of a liquid, okay, liquid vaccine. Now the condition is, if it is a liquid vaccine, the vaccine vial monitor must be put on the body of the vial. So now I am drawing you this one round, no, inner circle and outer circle. This is your vaccine vial monitor. This should be placed in the body of the vial. Okay, if it is a liquid vial, then you need to, if it is a liquid vaccine vial, then the vaccine vial monitor should be kept in the body of the vial. Suppose if it is a freeze dried vaccine, the vaccine vial monitor is placed on the cap of the vial or the neck of the ampule. Okay, so this is the cap. So here, okay, vaccine vial monitor will be kept over the cap of the vial, cap or the neck of the ampule. Okay, if it is a freeze dried vaccine. So freeze dried vaccine, where should you keep the vaccine vial monitor? Either in the cap or the neck of the ampule. If it is a liquid vaccine, where should you keep? In the body of the vial. Now, if the inner square is lighter than the outer circle, as I already told you, vaccine can be used. If the inner square starts changing color but is still lighter than the outer circle, vaccine can be used. If the inner square takes the same color as the outer circle, discard the vaccine. If the inner square is darker than the outer circle, you need to discard the vaccine. So this is all about the vaccine vial monitor. Now I have something known as shake test. So what is this shake test? So what is the purpose of vaccine vial monitor? Vaccine vial monitor shows whether the vaccine has been damaged by heat or not. Okay, so whether suppose the vaccine has been damaged by heat or not, that is what is the inference by vaccine vial monitor. Now how will you assess whether a vaccine has been damaged by cold or not? For that is why you have the shake test. So this shake test is done to assess whether a vaccine has been damaged, okay, has been damaged by cold, okay, by cold or not. So if you want to assess if the vaccine is damaged by heat or not, you need to do a check it by a vaccine vial monitor. And if you want to know whether the vaccine has been damaged by cold or not, then you need to do the shake test. So this shake test also, the second point is the same point, it also reflects the potency of the vaccine. Okay, shake test is also to reflect the potency of the vaccine. We have covered the part 1 of vaccines in community medicine. The part 2 will be in the next video in the playlist. So if you want to study more videos regarding this, please do stay tuned with